Hey, when things move, why do they do that? Why does that happen, and that happen, and that happen? Well, there's these little three things called Newton's three laws of motion, and you're about to learn about them, bucko. So here we go.
Hi, I'm Chance.
And I'm Nicole, and today we're going to teach you Newton's three laws
Of motion.
You might be wondering, Chance, why does that last video look like it's in 240p? Because the world does not want me to make this physics project. When trying to get the videos from Nicole's phone to my phone, they would only send in terrible quality, and we could not fix it no matter what method we used. So they're just gonna look like that. Bear with me, guys. When trying to record this part, my tripod and ring light broke, so I had to tape myself together a new thing to put my phone on. When we were trying to record the video, we were trying to go to altitude. It was closed. We went to Bolero.
They didn't have any lanes open, so we went here for no reason.
The world doesn't want you to learn about Newton's laws. They don't want me to make this. But guess what? I'm gonna push through. I'm gonna teach you guys about Newton's three laws, okay? You guys are gonna know. Newton's first law is that a body will remain at rest unless it is acted upon by an external force. And the same goes for an object in motion. It will stay in motion unless it is acted on by a force. Very simple, guys. If you don't do anything to something, it keeps doing what it's doing. Look at this dinosaur. It's important, I promise. So you see what happens when they go down on the trampoline. The dinosaur stays in place for a second because no forces are acting on it, so it doesn't do anything, except, you know, when gravity kicks in like immediately after. We were trying to recreate this clip. Look at Nicole on this swing. She's not gonna move unless Ethan pushes her, and then she is going to move until something slows her down, like her dragging her feet along the ground to hit the wood chips. Look at this ball on a table. Nothing's gonna happen. The forces on it are balanced until someone hits it with a cue. Newton's first law.
The second law of motion states that the force of an object is equal to its mass times its acceleration. If an object is acted upon by a net force, the change in velocity will be in the direction of the net force. The acceleration of an object depends on its mass. Hello? Oh my God!
So right here we have two bowling balls. One of them is 14 pounds, and one of them is 9. What do you think will happen when I hit them together? Let's see. See that? So you see how this bowling ball hit this bowling ball away? It's because this has more mass. And according to Newton's second law, mass times acceleration equals force, which means that this has more force knocking this out of the way. Back to you, someone.
I got a little chilly. So let's play pool. Why does this shot hit more balls than this shot?
Physics.
Well, the mass of the ball is the same, but the acceleration is varying because this one was hit harder than this one, so this one hit more balls.
Lock in.
Am I looking good? Newton's third law states that for every action there's an equal and opposite reaction.
Another thing you can use a trampoline for is that too. Also, Newton's third law of motion. What do you think about that, Bay?
That's crazy, man.
Okay, we're done. Okay, we're done.
Wow, look at me jump, guys. It's Newton's third law of motion. Everyone knows this one. It's why trampolines work. You push off the ground pushes you. Same thing with this swing. Very cool. Wow. Today, we learned all three laws of motion, and I think that calls for a celebration. Let's go to Whataburger.